Hi ladies, this is 4.1. This is about, we're starting to work with triangles now. So we've done a lot of constructing and a lot of talking about equidistance from certain points and duplicating angles and some of those characteristics and what we have to do in order to duplicate an angle or a segment. But this next chapter is all about triangles. So we're going to consider some of that stuff that we did in chapter 3. But we're going to work specifically with triangles. And the first lesson is about the triangle sum conjecture. So the first thing that we did in class was to discover and explain the triangle sum conjecture. So in class, what we did was we took a piece of paper and we cut out a triangle, or some of you just ripped off a piece of scrap paper and we got a triangle. Now with this triangle we tore off each of the corners of the triangle. So triangle corner A, corner B, corner C. We tore off those angles and then we fit those angles together, and I asked you to draw a conclusion. And that conclusion was the triangle sum conjecture. So you should have been able, I asked you to arrange those 3 angles to fit like a puzzle piece so that it forms a straight line. And with that, we concluded that the sum of the measures of the angles in every triangle, because it worked for every person in the class, the sum of the measures of the angles in every triangle is 180 degrees. So this is the conjecture that we're going to use in this lesson. It's not the only conjecture we're going to use, but it's our only new one. And so every triangle you have, all of the angles add up to 180 degrees. So in this class, we're not going to develop proofs, but we did have one vocab term, and that was auxiliary line. So an auxiliary line is a line that you draw on your diagram that helps you draw a conclusion. So here it specifies helps with the proof, but it could be any line that aids you in drawing a conclusion. So again, we're not going to write formal proofs in this class, but we are still going to use our conjectures in order to draw a conclusion. And that was our auxiliary line. Okay, so then on your note sheet, if you look at this extra example, and it's a little sloppy, so we're going to go through it again together. We already did it in class, but I'm going to do it again in this video. So the question is to find x. Well, we know 2 things. We know that the sum of the angles of a triangle in any triangle add up to 180 degrees, but we also remember our linear pair conjecture. And this says that if 2 angles form a line, then the sum of those angles is 180 degrees. All right, so let's look at this one. Let's look at this diagram that we have here. If we're using the linear pair conjecture, which we will need to do in order to find x, that's our goal, is to find that measure. Okay, so our linear pair conjecture says the sum of the angles that form a line add up to 180 degrees. So let's just call this angle A, this can be angle B, and this can be angle C. So we have 123 plus A equals 180. That means A equals 180 minus 123, so A equals 57 degrees. Now, if A equals 57 degrees, and A and B are congruent, then B also equals 57 degrees. So now we have angle A, we have angle B, but we do not have angle C. Well, we can use our triangle sum conjecture that says the sum of all angles in a triangle add up to 180 degrees. So that's angle A, which is 57, plus angle B, which is 57, plus angle C, which we don't know, equals 180 degrees. So that means 114 plus C equals 180. So that means C equals 66 degrees. All right, so now we know all three measures of the triangle angles, but we want to find angle X. How are we going to find angle X? Well, we can use our linear pair conjecture. So we know that 66 degrees plus angle X equals 180 degrees. So therefore, X equals 180 minus 66, which is 114 degrees. So that's how we're actually going to apply our linear pair conjecture and our triangle sum conjecture. So let's look at now this next problem on your note sheet, and it's the question is to find X. Well, we have an X here, we have an X here, we have an X here, but we're going to use our triangle sum conjecture. Triangle sum conjecture. That says that angle A plus angle B plus angle C equals 180 degrees. Now we don't have actual numeric measurements for each of these, but we have algebraic measurements. So angle A, this is angle A. So we can say 3x minus 10 plus angle B, which is x plus 1, plus angle C, which is 2x plus 3. And that equals 180 degrees. So now we're just going to use algebra. We're going to add our like terms. So our x's. So 3x plus x is 4x plus 2 more x. That's 6x. And then our non-x's. -10, 1, and 3. So that gives us 6x minus 6 equals 180. So now we can move the -6 to the other side. So that gives us 6x equals 186. And we can divide both sides by 6, and we get x equals 31. So now if we substituted 31 back into this, we should get a true statement. And this is just how we're going to double check. So it should be 3 times 31 minus 10 plus 31 plus 1 plus 2 times 31 plus 3. That should equal 180. And I just plugged it into my calculator, and it does. So 3 times 31 minus 10 plus 31 plus 1 plus 2 times 31 plus 3 does equal 180. That's how I know that this answer is correct. Okay, and then the next problem that we did in class, and this is, again, we're going to use our triangle sum conjecture. And we're going to use that to find angle Z, which we don't currently know. So the triangle sum conjecture, again, it says that the sum of all angles in any triangle equal 180 degrees. So let's start off with what we know. We know this angle right here. 120 is the exterior angle. We know that this forms a linear pair. So this angle here is 60 degrees. We don't know this angle, let's just call it x. And we know this angle here is 80 degrees because this forms a linear pair. And this also forms a linear pair. So this is 50 degrees. Okay, so that's basically what's given to us. All we had to do was apply the linear pair conjecture. Now here, we don't really care about this angle, okay? Because we're going to focus on the big triangle here. So we kind of know that we have to find angle x before we find angle z, but let's look at the big triangle. So in the big triangle, we have 60 degrees plus 50 degrees plus x. We know using the triangle sum conjecture that has to equal 180 degrees. So using that, we can find that angle x is 70 degrees. Now, you could do this a variety of different ways, but using the triangle sum conjecture, we're going to look at this big triangle. So if we know angle x is 70 degrees, this forms a linear pair. So this is going to be 110 degrees. So that's how you would use the triangle sum conjecture for this one. Now, some of you, and I think during class I showed you another little trick to find degrees of all polygons. Okay, so I'm going to erase what I have here, just to kind of show you another little trick. And you're going to get the same answer no matter which approach you use. But to find the degrees in any polygon, you can take the number of sides minus 2 and multiply that by 180. So in a triangle, we have 3 sides. So our total degrees in a triangle is 180. With a quadrilateral, we have 4 sides. So the total degrees in a quadrilateral is 360 degrees. So another approach you could have used that does not deal with the triangle sum conjecture, but the quadrilateral sum conjecture, is looking at this, do it in red, might be a little easier to see. Looking at this quadrilateral, you know that all of those angles have to add up to 360 degrees, because it has 4 sides. So it has to add up to 360 degrees. So if we do it that way, we know that this is 100 degrees because it's a vertical angle. We know that this is 60 degrees because it's a linear pair. And this is 80 degrees because it's a linear pair. This is 50 degrees because it's a linear pair. If we use the triangle sum conjecture to get this angle, we would have 50 plus 80 is 130, minus 180. We would get 50 degrees here, which means this has to be 130, because this would be a linear pair. Okay, and then if we use the quadrilateral sum conjecture, which we haven't formally discussed yet, but that's this little formula here, we would have 60 plus 100 plus 130 plus, again, let's just call this x. That has to equal 360 degrees. So we have 290 plus x equals 360. We still get x is 70 degrees. So no matter which way you do it, you should get the same, draw the same conclusion that x is 70 degrees, which makes z 110 degrees because x and z form a linear pair. So either one of those ways will work, but there's a couple different approaches, but really you should use the first method we discussed because that is what we're focusing on in this chapter. So please jot down any questions that you have, and we can go through them together next time I see you in class. Thank you.